Go.
Good morning. We have the first group. This is Justin, Indy, David, Jason, and Lizaveta. Welcome to Ronie. This is the robot we built. It's Arduino, and it has a sensor. Its original functionality was obstacle avoidance, but we wiped the original code and added line tracking so you can follow the line. We built all these buffers and put a ball on top to ensure its stability and smooth movement.
Alright, so yeah, essentially how Elizabeth said, we wiped the code and we went into the line tracking software and we found out ways to adjust it. And so here we have a demonstration. We built a track using electrical tape. It's a black line. And so the sensor works in 3 different sections and it adjusts itself to the width of the line. And so with this track we've noticed that we built it kind of like sideways and off. This was designed in order for it to be able to track it effectively and also see the reliability of the sensor itself. We also added the ball as a courier or passenger of sorts. Also can be used as a package or something else. And the little seat we have here is in order to hold it and so it doesn't fall out. And so essentially this is designed, we can use it in corporate environments or any other business applications to carry and transport things around a building. The tracks can be designed in any type of like dark tape or paint. And yeah, so.
Here, we have a few quick pictures of how we assembled Ronie. It was a huge team effort. We had everyone participating and deal with a lot of fine screws and circuitry. So luckily, we got it functional and working in the long run. So the main functionalities of Ronie, our robot, has Bluetooth connectivity with also an Android app. It has a proximity sensor with a servo motor. So over here, it can sense if there's anything in front of it, and it's on a motor, so it can actually pivot and see around its location. As the line tracking sensor, also has an IR receiver with a remote, and it can run itself autonomously via its either proximity sensor or the line tracking. So coding and programming, our robot is using its Arduino Uno chip. So we use the software, the Arduino IDE, to line, erase, and modify its lines of code. With it, we can change its angles of how it senses things, its speed, amongst its sensitivity on its proximity sensors. Also, the other software we're using is MBlock, which is based on Scratch. It's a drag and drop programming software to make it more user-friendly and easy to adjust its programming. And now I have Justin, our headmaster on navigating our robot, to go give us a live example.
The lines are a little thick, so you gotta help it a little bit, but don't move. There we go.
The sensor itself sometimes has some issues, but overall it tends to follow according to what we need it.
So now we can try the proximity sensor.
Yeah.
We could run it against the wall.
So we can test this on the floor.
And you can see its proximity sensor looking and searching for what's in front of it.
As of right now, the sensor can only sense a certain height off the floor. But
Yeah.
And not only that, we can also show, we can navigate it manually with either the remote or the Bluetooth. So you can maybe go forward, maybe spin around in circles, left or right, or even go in reverse. And Justin can do the same too.
Yes, so right here, move it, go forward, backwards, left and right, spin. And the idea behind the Bluetooth controller is that We can do the inputs on either the remote or the phone, and then it sends a Bluetooth signal or radio type of signal to the receiver, which is like right here. And then that sends information to the brain, and based off our programming, it will take our inputs and carry out those actions.
Any questions? Ryan.
Have you ever done a test where the robot reacts to wet surfaces?
No, not yet.
Not yet?
We don't really want to try that just yet, as in a lot of electronics are exposed, might be a hazard.
That's what we added the bumpers also because it would collide with a lot of stuff. And so just to keep it safe. And the sensor would also is kind of delicate at this moment, so we just try to keep it stable.
We've added extra protection around the proximity or that exterior of our robot, just in case any of the fine wiring won't get intruded.
All right, so to conclude, I think Ronie, the Arduino robot that we created, can have multiple applications to any sort of environment that you need it. It can be used for transporting packages, like we said, in a corporate environment. It can also be used like for schools to transport books and stuff like that. Maybe in a larger scale, it can be used to transport people. Who knows? And the technology in itself is very advanced, and we're proud to have been able to put it all together. Thank you.
Yep.